Good evening and welcome to my channel. Today we'll be looking at connection of solar panels in parallel. The connecting of several panels in parallel arises from the need to reach certain values of output current without changing the voltage. When panels are connected in parallel, the positive of the first panel is connected to the positive of the second panel. The second positive of the second panel is connected to the positive of the third panel. The connection continues from positive to positive to positive until we get to the last panel. Then the negative of the first panel to the negative of the second panel to the negative of the third panel, and the connection continues until all the negatives of the panels are connected together. After the end of the connection, we take one terminal out from the positive and we take one terminal out from the negative, from where all our measurements can be taken. We are going to study this parallel connection of panels under different panel conditions. The first one is parallel connected solar panel of the same parameter. The second is parallel connected solar panel of different current. And the third is parallel connected solar panels of different voltages. So look at the first one, parallel connected solar panel of the same parameter. So like you can see, panel 1 is 12 volts 5 amp, panel 2 12 volts 5 amp, and panel 3 12 volts 5 amp. So all the panels, they have the same parameter. So this calculation is straightforward. Since the aim of connecting panels in parallel is to increase our output current and maintaining our voltage, in this case, since all the voltages are the same, we take the voltage of one of the panel, which in this case is 12 volts, then our current is equals to the summation of the individual current of the panel. So we have 5 plus 5 plus 5, which equals to 15 volts. And our total power is current times voltage, which is equals to 15 times 12. That will give us 180 watts. Then we'll go to condition number 2, parallel connected solar panels of different current. So you can see panel 1 is rated 12 volts 1 amp, panel 2 is rated 12 volts 5 amp, and panel 3 is rated 12 volts 3 amps. So the calculation is still the same thing. Since all the panel voltages are the same, we take the voltage rating of one of the panel. Then for the current, we add the individual current of each panel. So we have 1 plus 5 plus 3, that will give us 9 amp. Then our total power again is equal to current times voltage, which equals to 9 times 12, that will give us 108 watts. Then condition number 3 is parallel connected solar panels of different voltages. So you can see panel 1 is 8 volt 5 amp, panel 2 is 12 volts 5 amp, and panel 3 is 18 volts 5 amp. So what we want to assume that since the panels have different voltages and the same current, what we want to assume that we'll just take the voltage and multiply it by the current, the voltage and multiply it by the current, the voltage and multiply it by the current. So if we assume that, that means the first panel is giving us the maximum of 40 watts, the second panel is giving us a maximum of 60 watts, and the third panel is giving us a maximum of 90 watts, making our total power to be equal to 40 plus 60 plus 90, which is equals to 190 watts. But no, our assumption in this case is wrong because when panels of different voltages are connected in parallel, the output voltage of the panel will be limited to the voltage of the lowest panel in the parallel combination. So in this case, the output voltage from the panel is equals to 8 volts. Then our total current as usual is equals to the summation of the individual panel current, which is equal to 5 plus 5 plus 5. That will give us 15 amp. Then our total power now be equals to current times voltage, which equals to 15 times 8, which equals to 120 watts. So it is clear that in this particular arrangement, the available power to the connected load is only 120 watts, which is clearly reducing the PV panel actual wattage to about 63% of the maximum. So in this case, you are wasting money on the purchase of higher wattage of panel. So that is why it is very important to note that before connecting panels in series, in parallel, if you want to achieve a maximum output, you must make sure that before your panels are connected in parallel, they must have the same voltage and current. So the emphasis here is the voltage. The current can be the same, the current can be different, but they must have the same voltage. Otherwise, if the arrangement is such that one of the panels has a smaller voltage, it is that panel that will takes over the total voltage of the PV array, thereby reducing your output power of the array. So to have a clearer understanding of this, you can try this particular question. So if you have this, find this video very useful, you can like, leave your comment, and subscribe to my channel. Thank you for watching.